I'm David.
And we did our project on lizards, keeping things toasty. Yeah. The overview. So the whole experiment was we'd have a heating gas chamber, and that would heat up, and we'd read in an ambient temperature, and we'd send that gas to 5 chambers filled with lizards, and we'd heat them up. And there'd be internal thermometers inside the lizards, which would read their internal temperature. And as they started panting or spasming muscle-wise, or they passed out, we'd click a time event on a computer, which David worked on, to record the time based on when it started. And we needed to maintain a steady temperature ramp for the lizards, which was 1 degree Celsius per minute. And then we would record in all the temperatures regularly. The background, we were working with Dr. Emily Taylor in the biology department, as well as our professor. I handled all the hardware side, and David handled the software side, which we'll see in a second. The hardware design, this is the background. So we have the Arduino Uno. This is the ambient temperature sensor. And we actually don't have the 5 lizard temperature sensors connected yet. So we just have a breakout board for that right now. We're assuming they're I2C. And we have a relay going to a heater, which we also don't have right now. So we're demoing that as an LED. So you can see it brighten up when you need to turn on the heater, or turn off when you need to turn off the heater. We have the Uno sending, so these temperature sensors send data to the Uno, PWM to the relay, and then the USART sends the data to the computer. That went backwards. Now they're both going backwards. There we go. So right now we're sending a 61 Hz PWM wave to the heater, which would be too fast for the relay. We did have it plugged in. The ambient temperature sensor specs are 1/4 degree plus or minus on the recorded temperature, in a range of -40 degrees Celsius to positive 125 degrees Celsius, and it's I2C communication. We also implemented a PID loop, so since ideally we want to heat up at 1 degree Celsius per minute, we need to make sure that it's actually doing that. So we have a PID loop, which stands for proportional, integral, and derivative. So we take the proportion, the difference between where it actually is and where we want it to be. We take the integral, so we take the area under the curve, and we take the derivative, so the rate of change, and based on those 3 concepts, we devise a certain rate for the PWM to run by, to either heat it up faster or slower. And then David will talk about the software.
Fortunately, we don't use that full -40 to 125 degrees because melted lizards and lizard cubes are not our business. So on the computer side of this, we have a GUI, graphical user interface, that controls the Arduino, tells it when to start ramping, what to do, and it also receives the temperatures. So this is an example where each individual lizard gets one of these controls, where you get to see its current temperature, which is also in text right here, and you can mark various events. So here's panting. I forget what LRR stands for. It's some physiological response they have, and then spasming, at which point when you hit that button, it's supposed to close off a valve to that lizard's chamber so it doesn't get any hotter, and then they'll physically remove the lizard from there so it can cool off and revive. All events get marked over here, so everything you mark on the lizard will have a textual component and will also come with the timestamp and the various temperatures of the lizard and the ambience at that point. And all of that's really important because the biology experiment needs all that data to run their experiment. That's really what they're interested in. And you can add various random notes as well. For the overall system, you also have an ambient temperature, ambient thermometer here, basically the same design. And then over there on the right side, you've got the controls that you can send to the Arduino. So there's an initial hold state of reach this temperature that is the start of the experiment. There's the ramping state, 1 degree Celsius per minute up to a certain max temp if you don't want to overrun the max. And then just an end experiment. There's also an emergency reset for in case things go horribly, horribly wrong. For the communication between the Arduino and the computer, we used the USART, but we threw away the whole ASCII component of it. The library that we were using before had echoing and did printing things on console, and that wasn't what we needed. We needed binary data to go back and forth. So there's 3 signals that the computer can send to the Arduino, just those 3 states, hold, start, and stop. Nothing terribly interesting there, just a couple 16-bit integers. The Arduino back to the computer has this variable-sized package format where he'll throw out a deadbeef so we know a packet's starting. And then he'll put out the ambient temperature and then a bunch of blizzard temperatures, however many he has plugged in. And then another deadbeef to mark that the packet's ending. And so the computer picks this up and just parses that out, figures out how many lizards were involved there, and uses the data correctly. So now for an actual live demo, because this is what you all came to see.
How many lizards do you have?
We have Alright, so when you boot up, you get this initial screen that's asking you for the state of the experiment, how many lizards you've got, and some various output results, some temperatures, as well as offers you various COM ports that the Arduino might be plugged into. We've only got one Arduino, so let's just go with that one. So it initializes to this, you'll see you've got 5 lizard controls, 1 for each lizard that we initialized. Down here you've got the ambient thermometer with no temperature readings in quite yet. So we will tell it to hold initial temperature, and you can see here that since the current ambient temperature is lower than what it's trying to get, the LED is on, which means it's trying to heat. So would you go ahead and heat us?
Well, for the whole temperature, I can just heat it for my body heat. I should be able to, unless it's much colder than it used to be. All right. Do we have a plug here? Start really close.
If you melt my hands off, I'll be okay. Alright, LED's off, because we're not warm enough. And we'll also bind that into the PID loop, so it'll hold that temperature even as you change various circumstances. So we hit the start. You can see it's trying to heat again, because it's trying to get higher than what the actual current ambient temperature is. I go ahead and heat that. And you can see over on the right side, you can see over on the right side our thermometer showing that massive increase up to 53 degrees Celsius because the hairdryer is much, much, much faster than 1 degree Celsius per minute. Ideally, the system, the PID loop, would control turning that on and off to make sure that we maintain that loop, even though the heat is much more powerful than that. But we don't have the relay wired into the hairdryer quite yet, so still working on that part. So that is the live interface. There's also a console version of that that is just for backup purposes, but this is the primary interface. So that's it. That's our project. Do we have any questions? Josh, I saw you had a question earlier.
Okay, so these are literal lizards we're talking about?
Yes, yeah. That they were going out and catching and sticking into plastic tubes.
Okay.